So in this video, I wanted to go over the IPv6 subnetting challenge that I put out over the past few weeks. If you got one of these packet tracers that had the last line, where the last set of instructions was to route this, don't worry about doing that. That is definitely a topic for course 2. So in this one, we're just going to focus on the first 5 steps here. Before tackling this, I wanted to go over subnetting IPv6 again. Let me go to the whiteboard for that. So IPv6 is a lot, I think, is a lot easier than subnetting IPv4, honestly. Let me just put up a routing prefix here. Yeah, so this is a 64-bit prefix. Each one of these hexadecimal numbers, they can be written in a 4-bit binary number. These are all 4 bits. Like 2 is 0010, right? A is 1010, I believe, 810. Yeah, 1010. You don't have to do all that to subnet IPv6, though. You don't have to write out all the binary. All you have to do is remember that each one of these hexadecimal numbers is 4 bits. So if I gave you a 64-bit prefix and I said I want you to subnet down to a /60, all you need to do is remember that it's 4 bits per number. So we're going down 4 bits. We're going from here to here. And we're basically, let's go back up here. We're basically dividing this at this point. We're going over one 4-bit number, we're going over 4 bits, one hexadecimal number. We're dividing here. So this would give us 16 subnets in IPv6. It would be 2001 ABCDEF01 2 3 4 0 would be our first one. 2 3 4 1 would be our second one. It goes all the way down till the last hexadecimal number, 234F. That's how you subnet if you're given a 64-bit routing prefix and are asked to subnet into the subnet range. What happens if you're given a 58-bit? So what if you're given this? Well, remember the 48 in the prefix, that's how many ones are in the subnet mask. Each one of these hexadecimal numbers is 4 bits. So if you count this out, you'll see that when we're talking about the first 48, /48, we're talking about the first 12 hexadecimal numbers, which is the first 3 hectets right here. Everything to the right of these ones are all zeros, same as what you would experience in IPv4 subnetting. So we can actually write out those zeros in this hectet here, just as a placeholder. Now let's say I asked you to subnet into a /52. What we're doing then is we're going here from the 48th bit and we're going to the 52nd bit. So we're going over 1. So we're dividing at this point. In this case, our first subnet would be 2001 ABCDEF01. I'll write that out here. :0000. Our second one would be 2001 ABCDEF01 ::1000. Second one would be the third one actually would be 2000, and it keeps on going until you get to the last hexadecimal, which would be F000. So why don't these last three numbers change? Well, because remember in a subnet mask, which is what these prefixes define, everything that's not a 1 is a 0. We're saying the first 52 ones, or the first 52 bits are the prefix, the routing prefix. Everything else is a 0, so they all get zeroed out. The example in the book, slot 8 up to 4, where you use the whole 16 bit subnet portion of the IPv6 address. But you can go either way. So in this packet tracer assignment, let's take a look and see what we were asked to do. Okay, so we're given a 64-bit routing prefix here, and we're asked to subnet into to a /56. So let's actually write this out on the board. Put this back out here. I'm going to show you, just because it's easier to write than on the screen here. So back to the whiteboard. So that's 2001 1 2 3 4 5 6 7 8 9 ABC. And we're specifying a /64 here. And we're being asked to subnet this to a 56. That is 8 bits. We're going from a 64 to a 56. That's 8 bits over. So we have to go over 2 hexadecimal numbers. So we're going to divide right here. Now it says to assign the first 4 subnetted routing prefixes to these 4 LANs in this packet tracer. So let's just write those out. And we'll also write out the last one because that's used for the WAN link. So 2001 1 2 3 4 5 6 7 8 9A00. It's going to be your first one. 9A01 would be a second. 9A02 will be a third. 9A03 would be the fourth, and we're to define the last one for the WAN link, which is 9AFF. That's our networks. So the first portion of this, the first step in this packet tracer is done right now. So it says assign the first 4 subnetted routing prefixes to our LANs. It doesn't say which order to go, but we'll just go, in order from left to right here. So go into configuration mode. First thing you do is enable IPv6 unicast routing. And I believe that is gig 00. Let me just double check that. It is. So interface gigabit 00, IPv6 address. And we're going to assign the first IPv6 address from each subnet to the router interface. Okay, so the first one is 2001, 1, 2, 3, 4, 5, 6, 7, 8, 9A, 00::1. This is the first IP address out of this prefix. We're going to use the first 64 bits as the prefix, even though we got 2 zeros here. We're still using the 64-bit as the prefix. Now, while we're here, it says to assign the appropriate link local address to each default gateway. So we might as well set the link local address on this as well. We're just going to use good old-fashioned, reliable FE80. Define it as link local. Enable the interface. Go to interface gigabit 01. Oh. And this one is 9A01. So it's 2001. We're using the first IP address in this prefix, which is ::1. Don't have a space between the IP address and the prefix ID. We can use the same link local address for each of these interfaces that don't have any other router interfaces connected. For instance, this is a stub network, so we can, each of these are 4 stub networks. So we can assign the same link local address to each one of them. They won't interfere with each other. And you would do the same for each of these. But I'm actually going to focus my attention now onto the WAN link. It says to assign the last subnet routing prefix to the WAN link and assign the first 2 IPv6 addresses to the serial interfaces. It's serial 010. Last interface is 9AFF. So it's 2001. We'll use it says they use the first 2 IP addresses for the link. We'll use the first one on this interface. We can use FE80::1 on this end. enable that interface. It's not going to turn green until we enable the other side. Don't forget we need to enable IPv6 routing. And we'll go to the serial interface. And this, we're going to use the second IP address in this prefix. And now for the link local, remember we're using FE80::1 on this interface, so we can't use the same one on this interface because they're on the same network. So we need to use the second one, or we could use, the last one, or whatever. We'll just use the second one. Enable the interface, and we're green. And that is how you do that. You would do these networks the same way. I'm not going to put you through watching me type that in. In fact, I'll let you handle that, but it is the same function as what I did for these two stub networks. And that's how you handle IPv6. We've done everything. Let's see. Assigned the first 4 subnetted routing prefixes. We did it on the whiteboard. Assign the first IPv6 address for each subnet. We did it on these two, but it would be the same process we're doing these two, and we set up the WAN link with the last subnet routing prefix. All right, if you have any questions, leave a comment below or send me an email. And have a great day.